Let's practice evaluating some integer exponent products and quotients together. For each of these given practice problems, we're going to go ahead and simplify each of these products or quotients, and we're going to go ahead and write each of these as a whole number or fraction without any exponents afterwards. For number 1, we have 3 to the second power times 3 to the fourth power. They have the same base, so what we can do is go ahead and add their exponents together. So that's going to be 3 to the 2 plus 4 power. If we do that, we're going to have 3 to the sixth power. Now remember, this is really just 6 3's multiplied together, so feel free to pause the video to try this part on your own, but you should get a total product of 729, which is the value of 3 to the sixth power. For number 2, we have 2 times 2 to the third power. Now keep in mind, this is really 2 with an invisible 1, so we're going to go ahead and add those exponents together because we have the same base, so 2 to the first power times 2 to the third power. So adding 1 plus 3, that's 4, so this is 2 to the fourth power. Now 4 2's being multiplied together is going to equal 16, which is going to be the value of this expression. For number 3, we have the same base of 4 for all 3 of these powers, so we can go ahead and use that product property. If we have 4 to the 7, but we have 4 to the 2, we're going to add those exponents, and we also are going to have this negative 6 as well. 7 plus 2 is 9, and 9 plus negative 6 is equal to 3, so this simplifies down to 4 to the third power, or 4 cubed, and that's equal to 64. Moving on to number 4, we have 5 to the negative fifth power times 5 to the third power. Because we have the same bases, what we can do is combine this into one power by adding their exponents together. So we have negative 5 plus 3. Negative 5 plus 3 is going to be negative 2, so we have 5 to the negative second power. Now 5 to the second power is just going to be 25, but 5 to the negative second power is just the reciprocal. It's 1 over 5 to the second power. So in the end here, we can say as a simplified expression, this is going to be 1/25. For number 5, we have a base of 8 all the way across. So we have 8 as our common base, then we have an exponent of negative 4. Since we're multiplying, we can add their exponents. So we're going to add 9. We're also going to add a negative 3 here. Okay, so negative 4 plus 9 is equal to 5, and 5 plus negative 3 is going to be 2. So this simplifies down to 8 to the second power, or 8 squared, and that's equal to 64. For number 6, we have a same base of 2 all the way across, so I'm going to write our common base of 2. We can go ahead and multiply this all together, and when we do that, we add their exponents. We have negative 6 plus 10 plus negative 7. Now negative 6 plus 10 equals 4, and 4 plus negative 7 is going to be negative 3, so this is going to be 2 to the negative third power. Now again, when we have negative exponents, we're going to write the reciprocal, so we're going to have here, this is going to be the same thing as 1 over 2 cubed, and that's going to be 1 over 8. For number 7, let's see what we got going on here. So we have a common base of 3, so we're going to go ahead and write that 3, and when we're multiplying all of these powers together with common bases, we can go ahead and add their exponents together. So we have negative 14 plus negative 5 plus a negative 13. Okay. Now 14 plus negative 5 is going to be positive 9, and 9 plus negative 13 is going to be negative 4, so we're going to have 3 to the negative fourth power. Okay, now we have another negative exponent here, so just figure out what 3 to the fourth power is, and that's going to be 81. So 3 to the negative fourth power is going to be the reciprocal, and that's going to be 1 over 81. Finally, for number 8 in this first column here, we have 6 as a common base. So we have an exponent of 1 that's invisible. We have 1 plus this negative 5 plus this positive 7. So we're going to go ahead and add all these exponents together because when we're multiplying powers that have the same bases, we can add their exponents together. 1 plus negative 5 is negative 4. Negative 4 plus 7 is going to be positive 3. So this is going to be 6 to the third power. Now 6 to the third power, or 6 cubed, is going to be 6 times 6 times 6, which is equal to 216. Now that we've practiced some products, let's go ahead and practice some quotients now on number 9. For number 9, we have a common base of 2, so what we're going to do here is write 2. Now, since we are dividing and have a quotient, when we go ahead and do this, we can go ahead and subtract their exponents, okay? So if we want to write it as one common base, so we have 7 minus 2 as the power. 7 minus 2 is going to equal 5, so we have 2 to the fifth power. Now, 2 to the fifth power is just 5 2's multiplied together, and that's equal to 32. For number 10, we are dividing again. We have another quotient, but we have common bases of 3. So as a shortcut, if we're dividing, we're finding the quotient, we can subtract these exponents and write 3 to the 8 minus 4 power. 8 minus 4 is going to be 4, so we have 3 to the fourth power, and 4 3's multiplied together is equal to 81. For number 11, we have a common base of 9, so we have 9 to the third power divided by 9 to the fourth power, And using a shortcut, we can go ahead and condense this and write 3 minus 4 power instead. Now 3 minus 4 is -1, so we have 9 to the negative first power. So if 9 to the first power is equal to 9, then 9 to the negative first power is just going to be the reciprocal of 1/9. For number 12, we have a common base of 2, and we are finding the quotient again. So this is going to be 2 to the negative 5 power, and we're going to be subtracting 8 because we are dividing here. Now, -5 minus 8, that's going to equal -13. So this is going to be 2 to the negative 13th power. Now, 2 to the 13th power is going to be 8,192, but 2 to the negative 13th power is going to be the reciprocal of 1 over 8,192. For number 13, it looks like we have another division problem, another quotient. We have the same base of 4, which is nice. So we can use this property. So we have 4 to the 9th power. We're going to take away the second exponent, so it's 9 minus a negative 12. So again, we can subtract these exponents because they have the same bases, and we are finding the quotient. Now 9 minus negative 12 is the same thing as 9 plus 12. So this is going to be 4 to the 21st power. Now, if you realize this is going to be a very large number, you are absolutely correct. And I'm going to estimate this and write it in scientific notation that this is roughly 4.398 multiplied by 10 to the 12th power. So this is an approximation, but it's pretty close to the actual number, but it's very, very big. 4.398 times 10 to the 12th power would be roughly this value written in scientific notation. For number 14, we have 5 to the negative 4th power divided by 5 to the 2nd power. So we have common bases and we are dividing. So we're going to go ahead and subtract their exponents. 5 to the negative 4th power, we're going to go ahead and subtract the 2. So it's -4 minus 2 as the exponent. Now -4 minus 2 is going to be -6. So we're going to have 5 to the negative 6th power. Now 5 to the 6th power is going to be equal to 15,625. So 5 to the negative 6th power is going to be 1 over 15,625. Last couple problems here. For number 15, we have another quotient with same bases. So we're going to have 7. We can raise this to the 5 minus 2 power. Now 5 minus 2 is going to equal 3. So we have 7 to the 3rd power. Now 7 to the 3rd power is equal to 343. Finally, for number 16, we have 2 to the negative 4th power divided by 2 to the negative 9th power. When we're going ahead and dividing by these with same bases, we can go to subtract their exponents. So it's going to be 2 to the negative 4th power, but we're also going to take away this -9. We're going to go ahead and subtract them. -4 take away -9 is just -4 plus 9. So that's going to be 2 to the 5th power. And that actually comes out pretty nice. That's going to equal 32. So there you have 16 different practice problems dealing with some products and quotients of powers that have the same base. If they have the same base and you are finding the product or multiplying, you could just go ahead and add those exponents together. And if you're finding the quotient or dividing two powers with the same bases, you can go ahead and subtract the exponents as a nice shortcut. The only problem here that we had to do a little bit of rounding was just on number 13, just because it was such a large number. So writing it in scientific notation helped with that degree of a large number. So hopefully you found this video helpful in learning how to deal with some exponents a little bit better. As always, keep with the great work that you're already doing, and I'll see you in the next one.